Okay, so for percent composition, what is the main equation that we're using?
It's gonna be
Mass of compound divided by total mass times.
Okay, Parker, I see you. She with those glasses. I need glasses. Like,
I know you said compounds, but your element. Oh, elements, yeah. Okay, that is what you said. Okay, mass of element over total mass of compound. Okay? You do that, and then you multiply by 100. Biggest mistake on the calculators that I have in here is people like to put the times 100 in there without parentheses or anything like that. Okay, and then it comes out like a crazy number. So make sure if you're going to do it all in one step, put those guys in parentheses. Okay? So for each of these, the biggest thing people forget is that those subscripts do matter, right? So if this has 3 nickels, you have to account for 3 nickels. Yeah? Bet you didn't see that one coming, right? All right. So if each nickel is about 59, we're going to round up, okay? So if each nickel is 59 grams, okay, for their molar mass, you need to do that times 3 in order to find your mass of your element, okay? So make sure you take into account all of your little subscripts, okay? Another thing about this one is, how does this 2 get distributed? Does it affect my nickel?
no.
No. Does it affect phosphorus?
Yes.
Yes. How many phosphoruses are there?
2.
Should I say phosphori? All right, there are 2. Okay. How many oxygens are there?
8.
8. Okay. So make sure you remember that when you are accounting for their masses. Okay. So that's that really quick. I'm not going to work it out. Look down at the bottom of your page at Empirical Formula. Let me give you the steps for that so that when we come in tomorrow, we can just do a, oh, yeah. we can do a quick warm up with it. Okay, so write down these steps. All right, so for empirical and molecular formulas. Okay, empirical is what, simple or true? This is the simple one, or simplified, okay? What is the molecular? True. Okay. So what that means is if you have subscripts that can be reduced down, because in molecular compounds sometimes that happens. We can't change those. An empirical formula would ask you to go all the way down to what is that 1 ratio, the lowest ratio you have. Okay.
So what true would be 2 to 8, and then simple would be 1 to 4.
Perfect. Yeah, so let's go ahead and put that. So what did you say? 1 to 4 for empirical, 2 to 8 for true. I don't know what I was going with that. Okay. All right. All right. So that would be how you would basically reduce it down. Okay. So what they give you typically are percentages. And we are going to learn, I need you to know the basics of empirical formulas so that when we give you, or when I give you a longer equation and I'm only accounting for a few of them, usually I don't give you oxygen, okay? You're going to have to know how to put it together, okay? So you need to use this empirical formula method. All right, so the first step, does anybody remember? We actually are not. Okay, so when you say you're changing it to a decimal, don't move it. Don't move that decimal. What we're doing is we're assuming a 100-gram sample. So therefore, I have 71.65 grams of chlorine. We're going to have that, and we will have 24.27 grams of carbon. And we will have 4.07 grams of hydrogen, okay? That's your first step. Okay, your second step. Once you have these, are grams things that you can compare chemicals in? Like, is that usually what we would compare chemicals in? No, they need to be in moles. They need to be in the same language. So we're going to convert to moles. Okay. And what's the easy way to do that? Well, yeah. So what is the simple step to go from grams to moles? We kind of did it quick yesterday. You divide. Good. Awesome. All right. So you're going to divide them all by their molar mass. But railroad tracks, yes, it's going to look like chlorine. I'm not going to put their true masses. Please forgive me. I'm just going to put approximate to keep our calculation simple. All right. So this is 35 grams for chlorine for every 1 mole. Okay. So you guys can kind of calculate that one. For carbon, it's about 12 grams for 1 mole. And for hydrogen, that's easy. 1 gram per 1 mole. Okay? So overall, you are dividing by molar mass. That's the shortcut. Okay? Okay. I do need these numbers to show you the next step, so as soon as you've got one, let me know who you're talking about and what you got.
Are we doing exact? Like to the second decimal place?
Yeah, let's just do that. That's fine.
Can I say one?
Mm-hmm.
For chlorine, it's 2.05 moles.
2.05 for chlorine. Okay.
2.02.
For carbon?
Yes.
Yeah.
2.02 for carbon and
4.07.
good. Awesome. All right. So your next step, does anybody remember?
Divide by the smallest.
Good. Divide by the smallest. Okay. What people like to do is they like to use that and go straight to the subscripts. Don't do that yet. You got to divide by the smallest because you're relating them. You need a ratio. Okay? All right. So I'm going to shrink this up. Who is our smallest number?
2.00.
Right. And we're going to see that this one's going to be approximately the same too. All right? But so this one you should be getting approximately, this is where you round. Okay? Approximately 1 for this one. This one for sure is 1. What is this one going to approximately be?
2.
A 2. Exactly. Okay? And now you have your subscripts. Okay? Now, if we had one that came out to be a 0.5. Okay? So this is a side note. If you had one that came out to be like 1.5, what would I have to do to all those numbers? I would multiply them by 2. Okay, so multiply all by 2. And if I had, I'm not going to write this down. If I had 1.25, what would I multiply all of them by? 4, right? If I had 0.33, what would I multiply them all by? 3, okay? So you cannot do a ginormous rounding on this, okay? Try to keep them as close to their true value as possible. All right, so knowing that, we now have chlorine is 1, carbon is 1, and hydrogen is 2. Okay, so this compound is actually going to be written CH2Cl, and what that is it should be methylene chloride. So it's spelled, and this isn't one that I'm going to require you to memorize. You're going to learn your aims and have those memorized at least by AP exam time. But this is who this is, I believe, okay? Okay, and then the last part of this question is asking for us to figure out that molecular formula, which we stated earlier was true formula. And so the useful information that they're providing here is this little line right here where it says, oops, I had totally crossed that out. All right, so let's try that again. this little section right here, okay, where it says the molar mass is known to be 98.96 grams per mole. So we have our empirical formula, okay? This is giving us information for our molecular formula. So what this comes down to is we have to make a ratio. So we're going to say molecular formula mass all divided by empirical formula mass. Okay, and so what we would do is they give us that molecular formula mass. So I'm going to go ahead and put that 98.96 grams per mole. And I'm going to divide it by the empirical formula mass. That empirical formula mass we have to actually figure out. And so chlorine is about 35, 2 hydrogens, and then a carbon who is 12. So I'm going to do this little math right here, 49. So it's like 49-ish, okay? Looking here, you can actually do this mental math. This is about 100. This is about 50. So it's a 2/1 ratio, okay? So what we're going to do with this special little 2 here is we're going to multiply it by all of our subscripts. So what this ends up being is we have our CH2Cl. I'm going to multiply everything by that 2. And so now we're going to have C2H4Cl2. And this is, I believe also, this one, you might have to double check me on this one, but I think it's dichloroethane. Okay? And so that is how you're coming up with your molecular formula using your empirical formula.